All right, so for IQE number 6, we have first question as why is the NPSH of a pump dependent on the fluid running through the system? And so this is essentially because NPSH is the necessary head into the pump in order to prevent cavitation. And cavitation is essentially caused by when the liquid evaporates, which is caused when the pressure in the fluid is less than the vapor pressure. And since the vapor pressure is different for every liquid, the NPSH will be different for every liquid according to this equation down here. Now for question number 2, if you're skydiving and you want to pull your parachute at the last possible second. It is 25 degrees outside and you weigh 100 kilograms with the skydiving equipment. And your parachute has a diameter of 10 meters. Find the initial terminal velocity and height you need to pull the parachute to decrease or decelerate to your terminal velocity. Neglect the human drag after the parachute is opened and utilize the average velocity to calculate the drag force of the parachute. And so we aren't given a whole lot in this problem. We're only given the diameter of the parachute, the ambient temperature, and your mass. And you're told to find the terminal velocity and the height you need to pull the parachute. As we're told in the problem, you can assume the drag force can be approximated by utilizing the average velocity during deceleration. You can neglect the human drag, and you can assume the diameter value for a human is 1 meter, which will be used in the Reynolds number calculation. Now from our properties, from the table we get density of air, G is obviously 9.81, viscosity, and then from another table, the drag coefficient table, we get the drag of a person is 0.84 meters squared, and the drag of a parachute is 1.3. Alright, so we start off with our velocity or terminal velocity calculation where we set force gravity equals to force drag. And so from that we can get our terminal velocity of the initial skydiving position to be 44.4 meters per second. Then we plug that into the Reynolds to double check our coefficient of drag, and we get a value that is greater than 10 to the fourth. So it is okay to utilize that coefficient of drag. Next, we can find the second terminal velocity after the parachute is opened. And we get that to be negative 4.02 meters per second, which does make sense because that is a survivable speed to fall at. And if we plug that into the Reynolds equation, we also get a value that is greater than 10 to the fourth. And so then from there, we calculate our V average, get our acceleration, calculate the time it takes to decelerate, and then from that, calculate the change in X or the height which we will need to pull the parachute.